So I'm going to record this from here on out. Okay, at least now we'll have the steps. Let me go back to my share screen. My apologies, guys. I'm uh, not the most tech savvy in the world. I will admit that. So, um, okay, so why am I two different things here? Just give me a second, guys. I'm trying to figure out why. I thought I had two different Excel spreadsheets open, but maybe not. Book one. Okay. All right, now, okay, hopefully you guys are seeing this as well. Somebody give me a thumbs up. Do you guys see Excel spreadsheet with two little blue graphs, two little blue bars? Yep, okay, thank you, Aria, appreciate it. Okay, all right, so, okay, so I think I can just switch back and forth then. I'll show you how to do this. Now, for those of you guys who have Mac, and again, I will want you guys to do this as we go through. But so for those of you who have Mac, what you want to do is click to your data, and you should have data analysis over here. Now, if you don't, I think what you need to do is go up to the top and click Tools, and come down to Data Analysis from your Tools menu, and you should be able to, I think that's how we did it. I've already got it set up in mine, so I don't remember. Or maybe it's, sorry, Tools. Maybe it's Excel add-ins. I think that's what it is. Yeah, okay, that's what it is, Excel add-ins. So you want the analysis tool pack. Just click that, click OK, and then when you go to this data menu, you should have data analysis over here on the far right. For those of you guys who have Windows machines, if you go over here, somewhere in this area, you have the like the Excel logo. You click on that, and it gives you like a green menu screen for your basic file things. And I believe you go down to the bottom for options. I'll have to look on my Windows machine later on, but you get down to options, and there should be somewhere in options where you add, just like it's called up here, Excel add-ins, and you want the analysis tool pack. And there's somehow you can do that. Again, I'll pull up my Windows laptop later on, and I'll record a video on how to do that.
Wait, so Mr. Eagle, so do you want us to open an Excel worksheet and then take that data that you showed us from that website and plan it in?
Yeah, yes. So what you guys would use, I put it up on, let's see, where's my Google Chrome? Okay, so I put it on Canvas here. So this book one raw data, this is that Excel spreadsheet that I've got open now. And
Okay.
yeah, so this is the spreadsheet that I've got open now. And then the example down here, this is, well, I'll show you when we get to it, but this is like an example of the abstract as well. So yeah, so what I'm kind of walking you guys through is what I want you guys to do over the next week. And basically, this will take you through having Excel do the t-test for you. So this should make it a whole lot easier than doing the t-test by hand.
Right.
So oh shoot, let me see. Okay, there, and then I need to click there. Okay, so now you guys see the Excel spreadsheet, right? Do you guys see? Okay, so you see the spreadsheet. Okay, all right, good deal. Okay, so then what we want to do with the spreadsheet is, again, you'll have to make sure you have this data analysis on here. So, and again, what I give you on PowerPoint or Canvas is just like this. It's just an Excel spreadsheet, just two columns. Okay, so you go over here to your data analysis, you click on that, and it's all sorts of statistical tests. I don't know a whole lot about statistics. I couldn't explain most of these. My wife probably could, but I don't use statistics like her and Dr. Camp do. But what you want is to t-test to sample assuming equal variance. Okay, you want the second t-test, and that's down here in the bottom. So just click on that, click OK, and you've got two ranges. You have variable 1 range and variable 2 range. Okay, these are basically your two different samples. So you just click on one, make sure your cursor's blinking on the open thing here, and it doesn't matter which one is which, okay, but you click on here, then you go and click, and I don't know if it's control click, or I think you just hold the mouse, but you click and select all these, go back, all these values in one column, and if you look, that'll tell you it's A2 to A52, just like doing a calculation in Excel. And then you go to click on your variable 2 range and do the same thing for the rural. And you select all those cells that have numbers in them, even if it's 0. And it should do the same thing. So now we've got B2 to B109. That's all we need to do there. Okay, everything else should be kind of already populated. That alpha 0.05, that should look familiar. That's our 5%. That's our probability of 5% or less of it being due to random chance. You click OK. And what that should do is open up a second sheet. If you look down here with the sheet tabs, you've still got that first sheet is right there. It opens up sheet 2, and this has your values on it. Now, if you can't see, it's really small, go down here on the right and zoom in. Just click the little plus, make it bigger so you can see it, and open your things up a little bit. So this is basically our t-test done for us. Okay, so we've got the mean for variable 1, the mean for variable 2, the variance for each one, the number of observations, which is our n value. I'm not sure what the pooled variance is. Again, I'm not a statistician. We have our degrees of freedom, which 157. So if you think about 51 and 108, add those together, that would be 159. All right, again, degrees of freedom for each one is n minus 1. So if you're comparing two variables, your total degrees of freedom would be 2 less. So there's our total degrees of freedom. If we wanted to, we could calculate our variance. Actually, we don't have the sum of squares. Our variance is calculated for us for each of these, 55.62 and 119. Okay, let me admit. Okay, sorry guys. Okay, how long have I been muted? I don't know how I
Over the
got
past 2 minutes, maybe.
crapola. Okay, I don't know how I got muted. Okay, let me go back here. Good grief. You gotta love technology.
Oh yeah.
All right, my apologies, guys. I didn't know I was muted there. So let me go back here just a second. All right, Nate, I can hear you. You tell me what was the last thing you heard me say,
It
or
was so I don't remember hearing an explanation about this table. That was pretty
okay,
much the last thing.
okay, the table. Okay, so let me just go ahead and step back a little bit. I don't know how I got muted. Sorry about that. So let's see. Okay, so I'll just go back a little bit, and again, so we've got our mean for each variable, and let's go ahead and plug these in. Variable one was our non-rural. Okay, so if we just type in here, I think we can just, yeah. And variable two is, well, is rural. Okay, so those are our two variables. And again, 14 in the non-rural and 4 in the rural. So if you think, okay, so per 100,000 people, there's an average of 14 overdose deaths in non-rural counties, they're in the high population counties, as opposed to 4.8 deaths per 100,000 in the rural or the lower population, the country, basically. And again, the variance is much wider spread variance in the rural. All right. And again, our observations, the N value, we have our degrees of freedom. This is total degrees of freedom. Again, if we took the degrees of freedom, N minus 1 for each of these, 50 and 107, we've got 157. And then our T values, 5.45. Remember, the important thing when we're looking at a critical value table was compare the T value to the critical value of 157 degrees of freedom. Okay, so let me go back to that little, if I can find it. Where is my, oh, did it go away? Okay, wait a minute. Okay, I want that to go away. And, oh no, where is it? Okay, let's just stop that for a second. Preview. Okay. Preview. Now I see it. Okay. Okay. Now, do you guys see the critical value table?
Yeah.
Okay. All right. Thank you. Okay. So I think this is, like I said, I just Googled for this, and this is the same one I think we looked at last week. So again, we're using a 5% significant level, the 0.05. So if we look at our degrees of freedom, we go all the way down. We have 120, and then we have infinity, 1.96. All right, so we are well above our, 5 point something T value. We are well above the critical value. So remember, if our T value is greater than our critical value, then that is telling us that the difference is significant and we reject the null hypothesis. And in this case, I'll just pull this up. In this case, our null hypothesis would be that there is no difference between rural and non-rural counties overdose death rates. So this is kind of what I have. I'll probably just put this on here and just have you guys kind of redo this in your own words. Okay, I don't want you just copy and paste it verbatim, because you are going to turn these in as a departmental assessment, and these are kind of they're looked over and graded in a way, but it's not like you guys get a grade for this. I mean, the only grade you guys are going to get for this is from me, and as long as you turn it in, it should be an easy 100%. But you do kind of it evaluates, I guess, the class in a way. But I made it easy last semester because this was my first time doing it. And be honest with you, the statistics, I'll be honest with you, I'm not that strong in stats. I don't use it every day. But after teaching it last semester, I understand enough to feel comfortable with it. This situation with us being over the internet basically is even more of a challenge. So I'm going to basically hand you guys everything that you need to do this. I just want you to retype it in your own words and things like that. But so what we're doing is, as far as our abstract, just simple title, what we're looking at: drug overdose death rates in non-rural versus rural Georgia counties and in the year. I noticed they have a new year of data up there since last semester. They had 2018, um, but we used 2017 last semester. So let's just kind of keep with that. We've got everything kind of done for us. No sense in reinventing the wheel. So data from the CDC suggests the number of drug overdose death rates have increased by 9.6% in 1 year. Okay, you guys probably all are well aware of this. The opioid epidemic is just that. It's an epidemic. It's um, people are dying from this that shouldn't be. And I was kind of surprised that I honestly thought the rural rates would be higher than the non-rural, because I always thought of this as kind of like a not really a poor man's epidemic, but definitely a working person's epidemic. I've read things that talk about a lot of people that get hooked on heroin and opioids are people who hurt themselves at work and end up getting prescribed some painkiller that's like OxyContin or some really strong painkiller, and it all starts out legitimate. They get a prescribed painkiller, and they get hooked on the painkillers, and once their prescription ends, they find it's easier to get heroin on the street than it is to get painkillers from a doctor or something like that. Um, so I'm not going to take around a poll of you guys, but I can imagine you guys know at least somebody. I mean, I know somebody that I grew up with that died of heroin overdose not too long ago in their 40s. They had a kid in their early 20s, and just not somebody you think of as your typical quote unquote junkie. But it's something that I think hits all of us in one way or another. So if you think about the background, that's the type of information you want in the background. Why is it important to study this? Okay, because you're looking at almost a 10% increase in death rate just from 1 year. All right, usually when people look at this things like that, they're comparing 5-year trends or 10-year trends. And the purpose, again, just kind of simply state why it is we're looking at this: to study, to investigate the number of drug overdose deaths in these two different county populations. And again, this is where you want to state your null and alternative hypothesis is under the purpose. All right, the null hypothesis simply predicts that there's no difference in mean number of overdose deaths between rural and non-rural counties. Alternative hypothesis predicts there was a difference in mean number of overdose deaths. Okay, so I mean those two statements should basically be very similar, with the exception of one states there's no difference and one states there is a difference. Okay, methods I give you. Okay, so that is given to you in that thing I showed you earlier that's on Canvas. And again, the number of drug overdose deaths per 100,000 people. Now, again, not all those counties have 100,000 people, so that number is raised up. If you've got 5 deaths in a county of 50,000 people, that would basically be 10 deaths per 100,000. Okay, so that's not the actual number of deaths; it's the death rate. Just kind of an important thing to keep in mind there. Tells you where we got it from the Georgia OASIS web address there for 2017. And again, the definition of the classifications. Okay, we want to know what rural means. All right, population of less than 35, and non-rural population of greater 35 in a county. And in the test that we're using, data analysis add-in in Microsoft Excel, a t-test assuming equal variances. Remember, that's the one that we selected. Use the test for any differences. So basically, you just want to kind of state this in your own words. Just don't copy it verbatim. That's really all I ask. And our results. Okay, so the results are, we've got data from 159 counties. And again, kind of spell out what you've got. You've got 51 non-rural, 108 rural counties. Results in the unpaired t-test indicate there was a significant difference. And you state your t-value, 5.45, and your degrees of freedom. And again, the two means between those two populations. So your mean of the non-rural and your mean of the rural. Okay. And again, our p-value less than or equal to 0.05 or 5%. So then our t-value is greater than a critical value, so we reject our null hypothesis, and we just simply state that. We rejected the null, the alternative hypothesis was accepted, when what do you see? Indicating there's a significant difference in the mean drug overdose death rates. And if you want to state the difference, you can see obviously the non-rural average was about, well, it's more than 3 times greater than the rural average. I mean, if you just think 3 times 4 is 12 something, so 4.8, whatever. You can say it's about 3 times greater, or it's significantly greater, whatever. Now, conclusions, I left this one kind of simple. But if you want to put some things into conclusions, like what you think could help based on these findings, which we should just, just said there should be increased preventative education and rehabilitation opportunities in non-rural counties. Some other things I thought of, or the group thought of last semester. There should also be some more, maybe more doctor education and alternatives to opioid painkillers. That's one of the big things I mentioned earlier. I think a lot of people actually get hooked on heroin and stuff through legitimate opioid type painkillers. I know when I was younger, when OxyContin first came out, that was the big thing, and people were getting robbed left and right for OxyContin pills. Maybe there needs to be some more education with doctors. And don't think, I think I harped on this last semester, don't think for a second that just because somebody has the initials MD after their name, that they could not use a little bit of education. When I did the organ procurement, and did that, I was around doctors all the time that didn't know the first thing about organ procurement or why I was doing what I was doing. They would look at me as like, why are you managing that patient? They're dead. Well, yes, they may be dead, but the 8 people that they could save with their organs are not yet dead. So just, doctor education could be a big thing as well. Just be creative here. Think of something that you think might help, educate people on the dangers of opioids, things like that. Or rehabilitation centers. There's actually right down the road from where I live, there's a church-based rehabilitation center that just opened up for I don't know if it's specific to opioids, but it's basically a drug rehab center. Okay, so once you've got that kind of written, again, the next thing I want you guys to be able to do is make a simple bar graph. And this is your example of that. You want kind of a quick and descriptive title. It doesn't have to be elaborate. And again, you want the 2 populations, all right, non-rural and rural. It doesn't have to have the mean. It just could, it doesn't have to have the mean on top, but it can. So let me show you kind of how to do that. Go back to my Excel. Okay, now this one I didn't practice. I haven't done for a semester. So let's just kind of go, see if I can remember how to do that. So we go to insert and go to chart. You want this first type of chart. You want the bar chart. And I believe it's just the first one, the 2D column chart. Okay, so that'll pop in there. You double click. I believe if you have a Windows, you would double click. If you've got a Mac, it would be command click. Let's see. Trying to remember. Select data. Yep, there we go. Okay. Okay, so under chart data range, this first one up here, you make sure you've got your cursor blinking in there. You click on that, then you would go over here and click on your 2 means. Select both of your mean windows. Okay, and that gives you your 2 Y values. Horizontal category axis labels, you click on that, and then you would click on these 2 bars with your 2 labels, the rural and non-rural, I think, and click on OK. Like I said, it's been a while since I've done that. Oh yeah, there we go. Yay. Okay, so that did. Okay, now If you notice, remember earlier I had, when I changed this, it said variable 1 and variable 2. If you now that you've got it linked in your graph that way, when you change the title here, say if I wanted to say rural and then put less than 35,000, hit enter. Now it changes it on the graph, if you notice. So it changes the value here. So since we selected these two cells, they are now linked to the graph itself. Okay. Now I think you can just, yeah, you just click on the title of the chart, and you can just type right there. Something like that, you know, and whatever. The other thing you can do, and again, I'll just, since I made it and defined it, I'll just define it in the other one. So again, your cells are linked to your graph now. So if you go to, I think it's insert, or where was it? Maybe it was layout. How did I do that? Give me a second, guys. I'm trying to remember how I did this. So when I did this last semester, I was using a Windows machine, and now I'm obviously oh, okay. Now I remember. So you click on your chart. Maybe if you're not, okay, you've got to click on your chart first, at least with Mac. I assume Windows is pretty much the same. And up along this menu on the top, you have chart design come up. And you go over here to add chart element, and you can add axis titles. So you want to add your, I would, primary vertical. And then this is just a clickable axis title, just like up top. So you could change this into, what was it, overdose, death rate per 100,000, something like that. Well, why not? Okay, whatever. Play with it, but that's how you add chart elements. The other thing you could add, if you want a data label, this is how I got the numbers on the top. Okay, I did a data label, and I had outside end there. You don't have to, but if you want to add the numbers to it. I think it looks good. I think that's really the only thing you need. And maybe you might want an axis title and a horizontal as well. I don't think so, though. It's not necessary. If you've got the rural versus non-rural and you've got a decent title to your graph, I think that should be sufficient. But just kind of looking, see what I did last semester. Yeah. Yeah, so this is kind of what I did last semester. I didn't have an X label, but you should have a Y label, and you can spell out what those numbers mean. They're the overdose death rate means per 100,000 people. Okay. So, like I said, I will record this, or I've got this recorded. I'll put this either up on Canvas. Or a link to YouTube or something like that. and probably do a quiz on something like this as well. I'm not sure exactly what quiz I would do, but maybe I'll do a conglomerate of the last couple of weeks material, something like that. Okay, so the big thing I want you guys to do is to play around with your Excel a little bit. Again, I expect you guys to have to go through this video. If we were in class, I would go to each and everybody's computer and kind of show you how to do this. But it's just not possible at the moment. But what I will do, I will probably do a kind of more consolidated video on how to get the data analysis tool up on a Mac and on a Windows. I'll put Zoom on my Windows laptop, and I'll record a video of me doing that as well, and put both of those up on Canvas as well, and just again to kind of do a walkthrough to pulling up that data and creating a chart. Okay, so basically what I want you guys to do, I'll tell you what, I'll make it, let's make it your goal to do it over the next week. That way, if you've got questions, you can, we can meet next week. And it doesn't have to be on Monday. I can get together with you guys anytime you need. But your raw data is here. The example abstract is here, which is basically the abstract that I had minus a little bit. I just pulled the, well, that's not the one I'm looking for. Where is it? Blank. There we go. So I left the background and the purpose out. Again, so the purpose, again, I want you guys to state your null and alternative hypotheses. You've got the methods, you've got the results, and a conclusion statement or two. And again, it only has to be 1, 2, 3 sentences. What you saw. Obviously, there's more overdose death rates in the non-rural counties and the higher population counties. So maybe those counties need targeted for, opioid epidemic education and things like that. You guys are in college, so you're getting an education. But what you don't realize is there's a lot of people out there who don't have education, and some people even think that education is bad for you in some way. I mean, ignorance spreads sometimes, but put in a few statements of something you think that would help with this whole epidemic thing, and we've kind of talked about that, from patient education to doctor education to alternative painkillers, other than opioids, things like that, non-addictive type of things, or even like meditation therapy and things like that. There's a lot of alternatives out there to alleviate pain than just throwing an opioid at it. So all right, so that's kind of what I want you guys to do. Be on the lookout later on today. Like I said, I'm going to put some more stuff up there. I'm going to put that walkthrough on a Windows machine and on a Mac machine, and I'll put those up on Canvas before the end of the day today. But let's make it a goal of at least trying to get the numbers pulled up and all that stuff within a week. That way, if you guys have questions, you can get a hold of me and get those questions out, and then you still have another week in order to actually get those done and turned in. I guess the other thing is, once you get these abstracts done, there is an email address I want you guys to email them to. It's in the syllabus, but I'll put another little blurb up on Canvas as well, just telling you've got to label it and title the file in a specific way, and you got to send it to a specific email address. So I'll kind of cut that part out and rehash that on Canvas, just so it's right in front of you. But when you do go get to turn in the abstract, you're going to email it to me, and I believe it's just gened@piedmont.edu, but I'll double check the syllabus and get back with you guys. And I believe that's probably about it. If you guys have any questions, I'll hang out here.